Here is an application problem on factoring. The length of a photograph is 1 centimeter less than twice the width. The area is 45 centimeters square. Find the dimensions of the photograph. So for a word problem, it's good to start with assumptions, right? And defining variables. Now in this particular case, we can define the variable, which is let the width be W. In that case, what is the length? And let width be W and length be L, let us say, right? It says the length of the photograph is 1 centimeter less than twice the width. In that case, length is twice the width minus 1. 1 centimeter less than twice the width. That is kind of important. Some students will write 1 minus 2W. That would be wrong, right? So that is what it is. Now if length is twice the width minus 1, then that is how they are related. What is the area? It says the area is 45 centimeters square. So area is length times width. In our case, length can be written as 2W minus 1, right? So area is 2W minus 1 times W. And what is the area? Area is given to us as 45 centimeters square. We can write 45 is equals to 2W minus 1, right? Times W. So that is the relation. Now this relation is in one variable, and from here we can always find what W is. So let's multiply, open it up. So we get 2W squared minus W, and we can bring 45 to this side, minus 45 equals to 0. So we get a quadratic equation in W. Now this quadratic equation can be solved to get the result, right? So that is how you can get answer for such a problem. Now to solve it, we need to factor 2W squared minus W minus 45. That means we're looking for two numbers whose product is 90, right? So we are looking for two numbers whose product P and Q equals to 2 times minus 45. That means minus 90, and the sum P and Q should be minus 1. So that is what we are looking for. So the two numbers are very close to one another. Therefore the difference is just 1. So these numbers should be 10 and 9 for us. So 10 and 9, a bigger number is positive, right? Since a bigger number is negative, since we add them to get negative. So it's minus 10 and 9, right? So if you do minus 10 and 9, then you get sum as minus 1, right? That is how you could get it. So let's factor this. So you could write this as, let me move on to this place, 2W squared, and we will decompose minus W as minus 10W plus 9W minus 45. And now factor this. So in these first two, let's group them. So you can group two each, right? So in the first two, 2W is common. So we get 2W, W minus 5, and here 9 is common. 9, W minus 5. And now you can factor W minus 5, getting 2W plus 9 as the second factor. So from here you get two answers. One of the answers is W equals to 5. The other one is W equals to minus 9 over 2, right? That will make it 0. But since this is not valid, our dimensions should be positive, correct? But this is okay. So we can work with W equals to 5. So we have width equals to 5 units a centimeter, and length is 2 times W, that is 2 times 5 minus 1, that is 10 minus 1 or 9 centimeter, correct? So the dimensions of the photograph can be written as length by width, which is 9 centimeter by 5 centimeter, right? So that is the dimension of the given photograph. If you multiply, you do get 45 centimeters square, and you can also check that length is 1 centimeter less than twice the width. 2 times 5 is 10, minus 1 is 9. So both ways it works. So that is the answer for this particular question. I'd like you to go through the solution once again. So first define your variables, and that is, in this case, let width be W and length be L. And remember, W and L both will be greater than 0, right? Otherwise, you just can't get the dimensions, right? They cannot be negative numbers. Now, area is length into width, and you know the relation between length and width. So relation helped you to write down equation in one variable. Once you get equation in one variable, you can get the answer. And then write down the answer clearly with units. That is what is important for solving such questions. I hope that's clear. Thank you.